Hey, Mrs. Radigan with a lesson on geometric sequences. A geometric sequence is a sequence in which a term is equal to the previous term multiplied by a constant. That constant is called the common ratio. The recursive formula, or the formula that uses the previous term, is a sub n equals a sub n minus 1 times r. And the explicit formula, which means you can define any term in the sequence, is equal to a1 times the ratio r raised to the power of n minus 1, where an is any term, an minus 1 is the previous term, a1 is the first term, n is the number of terms, and r is the common ratio. If you want to find the ratios between consecutive terms, you divide the second term by the first term, or divide any term by its previous term. If all the ratios are the same, it's geometric. If you want to find the second term given the first term, you just use the common ratio to multiply the first term by r, and you get the second term. The geometric mean of two numbers is just the square root of the product of the two numbers. So in the first example, we are determining if the sequences are geometric, and if so, finding the common ratio. So we want to take the next term, divide it by the previous one, see what the ratio is, continue to see if all of these give us a common ratio, and 54 divided by 18 also gives us 3. So this is a yes, r is equal to 3. In the second one, if we were to take a fourth and divide it by a half, we would get a half, but if we were to take 0 and divide it by a fourth, we would get 0, so this is a no. This is actually arithmetic. And the common difference is equal to negative 1/4, because if you took a half and subtracted a fourth, you would get 1/4. If you took a fourth and subtracted a fourth, you'd get 0. In part C, we want to take 34.5 and divide by 32. That gives us 1.08. If we take the next term, 37, and divide by its previous term, 34.5, we get 1.07. So this is a no, not geometric. And in the last one, if we take 90, divide by 135, we get 2/3. If we take 60 and divide it by 90, we also get 2/3. And so on. If we take 40 divided by 60, we get 2/3. So these have a constant ratio, so this is a yes, and r equals 2/3. In this example, we're asked to write a recursive formula, which I gave right here, the explicit formula, which I gave right here, generate the first 5 terms and the 15th term. So we're given that the first term is 5 and the multiplier in the sequence is negative 3. So if we want the recursive formula, we just write the nth term is equal to the previous term times the ratio of negative 3, and that would be the recursive formula. If we want the explicit, we take the first term, which is 5, multiply it by the ratio, which is negative 3, and raise it to the power of n minus 1, and that is our explicit formula. If we want to find the first term, it's given, so we know that's 5. If we want to find the second one, we're going to take 5 times negative 3, which is equal to negative 15. If we want to find the third one, we want to take a negative 15 and multiply it by negative 3, and that gives us 45. If we want to find the fourth term, we're going to take 45 and multiply it by negative 3, and that gives us negative 135. And the fifth term, we would take negative 135, multiply it by negative 3, and we get a positive 405. So that would be the first 5 terms. If we want the 15th term, we probably want to plug it into our formula. So A15 is equal to the first term, which is 5, times the common ratio, which is negative 3, and raise it to the 15th term minus 1. So we're going to have A15 is equal to 5 times negative 3 to the 14th. If we want to type that in our calculator, we're going to enter 5 times negative 3 raised to the power of 14. Hit enter, and we get an answer of 23,914,845. In the third example, we're finding the missing term in the sequence by finding the geometric mean. Remember, the geometric mean is just the square root of the product of the two numbers. So this is going to be the square root of 36, which is 6. In part B, we're taking the square root of the fractions 3/4 times 27 over 4. We multiply straight across, and we get the square root of 81/16, which is 9 over 4. In part C, we have to find 3 geometric means. So we are going to first find the geometric mean between 12.5 and 5.2. So we want to take the square root of 12.5 times 5.2, which is equal to 8. Then we want to find the geometric mean of 12.5 and 8, so we take the square root of 12.5 times 8, and that gives us 10. But this one could actually be a positive or a negative, because if we had a multiplier that was a negative, we would go from 12.5 to negative 10 back to positive 8, or it could just be a positive multiplier. And the last one is we want to find the geometric mean between 8 and 5.12. So we multiply 8 and 5.12, square root it, and we get 6.4. This one, again, could be a positive or a negative. In example 4, we are given A2, and we need to find A1. We also know that A5 is 405. So we don't know what A1 is. We know A2 is 15. We don't know what A3 or A4 are, but we know A5 is 405. So similar to what we did in section 9.2, we know that we start with 15, and we have to multiply times R, times R, times R 3 times to get to 405. So we could simplify this to 15R cubed equals 405. Then we just solve our function, divide by 15. We get R cubed is equal to 27. So we know R is equal to 3. So if we know that R is equal to 3, we could work backward, and we know whatever is in the first spot, we have to multiply by 3 to get 15. So we know that would be 5. Or you could set up an equation that A2 is equal to A1 times, we now know our R is 3. Since this was n equals 2, we would put 2 minus 1 in the exponent. and then we would simply solve. So we know 15 equals A1 times 3, and again we get A1 equals 5. Okay, similar to the last example, looking for A1. This time we don't know A1 or A2. We know A3 is 40, A4, A5, A6, and A7 is 5 halves. So in this case we have 1, 2, 3, 4 multipliers. So we start at 40 and we multiply 40 times r 4 times, so r to the 4th to get to 5 halves. So now we just need to solve this. So instead of dividing by 40, I'm going to multiply by 1 over 40 since this is a fraction over here. So we get r to the 4th equals 5 over 80, which is equivalent to 1/16. And if we take the 4th root of both sides, we get r is equal to 1/2. Okay, for the last example, we're going to do a story problem here. So we purchase a computer for $2,000. It loses 10% of its value each year after the first year. So we're going to write a geometric sequence that shows its worth at the beginning of each year for 3 years. So at the beginning of the first year, it's still worth $2,000. It doesn't lose its value until after that. So at the beginning of the second year, it's worth $2,000 times 90% of it if it lost 10% each year. And at the beginning of the third year, it's worth $1,800 times 90% of that previous year, which is equal to $1,620. So we see there that the common ratio is that 90%. If we want to know how much this will be worth at the beginning of the 7th year, we're going to take the value at the first year, multiply it by our common ratio, raised to the beginning of the 7th year minus 1. So A7 equals 2,000 times 0.9 to the 6th power, which is equal to $1,062.88. And in summary, we now have learned about geometric ratios and arithmetic ratios. Remember, arithmetic is a common difference. And geometric ratios or sequences have a common ratio. And that's it.